Hey guys, welcome back to another Calculus 3 tutorial. So today we'll be evaluating a double integral that represents the area of the region bounded by y equals x squared, y equals negative x plus 12, and y equals 4x plus 12. So what we're doing is that we're setting up a double integral and then solving it. We're given this region that's bounded by these three curves. All right, so this is what the problem is basically saying. And the first things first, I see that we have these three regions. So why not just draw it out and see what it looks like. So the first curve we have is y equals x squared. And this curve looks like this. Next, we have y equals negative x plus 12. So we're starting at 12 right here. And we have a slope of negative 1. So that's about right here. Draw a line. So this one is the red one. And this one's the blue one. And next, we have y equals 4x plus 12. So again, we start at 12, but this time we have a steeper slope that is positive. So we draw a line that's like here. And now we can see that there is some points of intersection here. So we have this point that's intersecting, this point that's intersecting, and this point is intersecting. And we already know what this point is. This point is going to be 0, 12 because that's the y-intercept of both of these lines. And what about these 2 points? We need to know what the intersections are. So how do we find them? So we can actually set them equal to one another and then find the x and y coordinates. So what I'm going to do is this. X squared would equal to, I'm going to solve for this intersection first. So I'm going to use this line right here. So x squared equals 4x plus 12. And then I'm going to move it to the other side, x squared minus 4x minus 12. And then I'm going to factor x minus 6 and x plus 2. And we have the x-intercepts of x equals 6 and x equals to negative 2. However, since we're dealing with the negative region right here, we only care about the negative x-intercept. So this is going to be negative 2. And plugging negative 2 in to y equals x squared, we get y equals 4. So this would be 4 right here. All right, now let's do the same for the other side. We have y equals x squared, and what I'm going to do is I'm going to set this equation to y equals x squared. So it's going to be x squared equals to negative x plus 12. I'm going to move it to the other side. And then we're going to factor. And that's going to be factored into x plus 4 and then x minus 3. And we get the x-intercepts of x equals negative 4 and x equals to 3. And that is all the intersections we have right here. We're asked to find the double integral that represents the area bounded by all these three curves. So the region we're interested in is actually the area bounded between all these three lines. So it's going to be this region that we're interested in. Okay, this region inside here. Since we have a region right here that is not symmetrical, we have to break it up into two different double integrals to solve. So I'm going to break it up into the negative side and the positive side. So I'm going to label this negative side region 1, and then the positive region, region 2. And remember in the last video how I set up the double integral? You have to set it up in terms of dy dx or dx dy. But since dy dx is usually easier, I'm going to use dy dx instead. So what we do is that we're going to draw a vertical line from here to here and another vertical line from here to here. So we're going to set up the double integral here, dy dx. This is going to be region 1 plus double integral dy dx. So we're going from the above function to the bottom function. So the above function is going to be y equals 4x plus 12, and the bottom region that's bounded is y equals x squared. So let's just write the above function, y equals 4x plus 12, and y equals x squared. And then right here, we have the top function, or the above function, is going to be y equals negative x plus 12, and the below function that's bounded is y equals x squared. So we're gonna put it right here. Y equals negative x plus 12, that's the above function, and y equals 2x squared, that's gonna be the below function. All right, how about the outer bounds? It's going to be the x bounds. So we have x equals negative 2 right here. X equals negative 2. 2 is going to go from negative 2 to 0, since we only care about region 1 right here. So x equals negative 2 to x equals 0. And we have x equals 0 for region 2, and x equals 2, 3. All right, and since we're evaluating the area, the inside is just going to be 1 right here. Since dA is equals to 1 dy dx, right? So that this is what we're basically evaluating. And now that we have done setting it up, we can actually solve this problem. So we have these two integrals. I'm going to evaluate the first one first. So the integral of dy, that's going to be y. Evaluate that from x squared to 4x plus 12. That's going to be 4x plus 12 minus x squared. And we're going to integrate dx from negative 2 to 0. So that's going to be 2x squared plus 12x minus 1/3 x cubed. And I'm going to evaluate that from negative 2 to 0. So that's going to be 0 minus negative 2 squared, that's going to be 4. 4 times 2, that's going to be 8. Negative 2 times 12, that's going to be minus 24. And then negative 2, plug it in here, that's going to be 8, negative 8. And then negative 8, we have a negative right here, so that's going to be positive 8/3. This expression finally evaluates to negative 40/3. And this is going to be evaluated to negative 40/3. And since we have a negative in front, we get a 40/3, positive 40/3. And so that this first one evaluates to 40/3. And now we have to evaluate what is the second one. Okay, integral of dy, that's going to be y. Evaluate from x squared to negative x plus 12. We get negative x plus 12 minus x squared. And then we integrate from 0 to 3. And we have negative x squared over 2 plus 12x minus x cubed, 1/3 x cubed, and then evaluate that from 0 to 3. And now we plug it in. So 3 squared, that's going to be 9, and that's going to be negative 9 over 2 plus 36 minus, so 3 times 3 times 3, that's going to be 27 over 3, which is going to be 9. And all of that simplifies to 45 over 2. So all of this simplifies to 45 over 2. So I know this is 45 over 2. We have to combine the results. 40 over 3 plus 45 over 2. And that gives us the final answer of 215 over 6. So this is our answer. Alright guys, thank you so much for watching, and remember to subscribe for the next video. Bye!